So we've been telling you all afternoon about STEM, science, technology, engineering, and math. STEM.
Here's what else STEM stands for. Spectacular, terrific, excellent, and magnificent. That's because STEM is making a huge impact on young students' lives. Students like Connor Newton, 4-H STEM educator with the University of Maryland and Extension. Bradley Hartle also joins us this afternoon. Thank you for being here.
Thanks for having us.
All right, so throughout the years we've learned that STEM rocks, right? So give us an overview of STEM.
So STEM, like you said, is science, technology, engineering, and math. It's both the separation of them and the bringing together of those topics and bringing arts into it as well. So sometimes we'll refer to it as STEAM as well. But it's really trying to focus on getting youth more interested in, say, the sciences, the technology, the engineering, and finding fun ways to connect with math.
So Connor, obviously you enjoy STEM or you wouldn't be here in the first place.
Yeah.
Why do you like STEM?
I like it because I like to see what happens and if you add Mentos and soda, it explodes.
What happens?
Stuff like that.
Okay, well that makes sense.
Well, I don't see Mentos, but I do see some bottles of water here. You're going to actually show us a little experiment? Mm-hmm. What are we going to do here?
Yeah, so this is our Cartesian Diver. So inside the bottle, this is a top half of a pipette, so that you would normally squeeze to get the liquid into.
Oh, okay.
We're going to use a straw as an example because it gives a little bit more color. But you add the clay to it, and when you actually pressurize, it sinks down to the bottom as long as it doesn't hit your thumbs. And when you release, it comes back to the top.
Wow.
So Rene Descartes was actually the one that first kind of made a model of this, and it goes into buoyancy, density, a whole bunch of more scientific stuff that I won't get into today. But
you understand all that. You get why it does that.
Kind of.
Kind of.
Well,
Getting
let's
there.
start, yeah.
All right,
Can you show us how to
so
do it?
let's start. What do we need to do?
All right, so you need, in this case, I've cut down a piece of straw. This is normally a bendy straw that you can fold over the bend and cut it. This is the other half. Need a small amount of clay. This is modeling clay. You want to make sure it's not the air drying clay because if you put that in the water, it starts to disintegrate over time.
Yeah.
This is just a spare cup of water to test, and then our water bottle with water in it.
So we're going to try the Cartesian Diver.
Yep. So, Connor, I'm going to give you the straw. I'm going to take a little bit off of this.
I was going to say, is it just like a rough guess how much to start?
Yeah, I've gotten pretty good at doing it the first time, but it's always kind of, it's that science, technology, engineering. You're never right the first time. So even with something that looks really simple to make, it takes a couple of tries, which is why I have that extra cup of water to be able to do. So what you do, and I'll kind of do one with him, you're just taking the clay, you fold that straw right in half, and then you're just modeling the clay right around the straw. And
so that it seals both ends.
Yeah, so it seals both ends, and what it does is it seals that air into the straw.
Right.
And so then when you pressurize that bottle, so when you squeeze it, the air inside gets pressurized as well. So it's the same thing as if you go up in an airplane or if you scuba dive. When you go down in the water or dive deep in a pool, you have to pressurize your ears because you have that air in there.
Okay, so Connor, if this doesn't work first try, what do you do to adjust it to try to make it work better?
Maybe take off the clay or add a little bit more to kind of even it out.
Okay. All right, so try. I want to see it.
Yeah, so do
So in this case, it sinks down. I'll actually grab it out for you. Because it sank, we have a little bit too much clay on there. So what we can do is if you just want to take a small amount off.
This is a fun way to learn a practical application that could take him a long ways in adult life.
Yep, and it's one of those things that I've done with AP physics classes all the way down to first and second graders, or at, say, an exhibit table, so that they can come up, we make them really quick, and they can go on their way. It's a nice little toy that they can play with.
And you suck them right in.
Yep.
And UMES has a STEM event coming up, a festival?
Yeah, so it's called the UMES 4-H STEM Festival. This is our 6th year of doing it, and so that's exactly where you want the straw to kind of float, right at the surface. And so then what we can do is take the cap off the water bottle, and then go ahead and place that in there. And then if we cap it back, when
There you
squeeze
go.
it goes right to the bottom.
I mean, you did this, and
in
suddenly
this
I'm like
case,
proud of you.
It's going to take a little while. So again, this goes into that. Sometimes once you put it in the water bottle, it's going to work perfectly. This one I've had for like 3 years, so I know it works perfectly. This one, it might take a couple little
You just
bits
did
of
it a couple
adjustment.
minutes on TV. That was
Yeah,
great.
that's great.
And so with the STEM Festival, that's really what we're looking at, to really have tables to do that kind of hands-on experiments. Try this one.
I'll try this one.
do that one.
Since
All right.
that one we know,
And I tell you,
that'll take a couple more tries to kind of tinker with, because it's floating back to the surface right now.
There you go.
there it goes. Well, I tell you what, we'll have the information about
Yes.
the festival on our website, delmarvalife.com. Thank you so much. This
Yes.
is really fascinating.